Okay, today we are doing day 2 of section 8.5. We are going to use the change of base formula, which we practiced last week, to solve an exponential equation. We are also going to solve log equations. Should be fun. For our warm-ups, we are going to evaluate by changing to exponential form. So this is what we did a while back. If we are changing to exponential form, these are, the ones where I would set them equal to x and then change the form so that there is not a log in there at all. So what base would I use? 2. My base is 2. What exponent goes on the 2?
X.
The x from the other side comes over. And then that gets set equal to 2, the big number. So 2 raised to what power equals 2? 1. So x equals 1 in this case. You remember using exponential form? We're bringing them back. So number 2, we again could set it equal to x, or you could use a y if you want a different variable, something else. What am I using as my base? 5. My exponent equals 5 to what power equals 5? The first power, so x equals 1. Any guesses about number 3?
X equals 12 or 1.
It would equal 1. So again, if we do exponential form here, our base is 12 raised to the x power equals 12. X has to be 1 again. So even on number 4, when we don't have numbers, we just have letters, what do you think that log would equal? What do we think? 1. Okay, so our base is b. We could raise it to the x power equals b. It's still going to have an exponent of 1. So if you take the log of some base of some number, and the base and the number are the same exact thing, then that simplifies to just be a 1. Does that make sense? So that's an idea that we're going to use today.
So is that the change of base form?
No, change of base was what we learned last week, where if we were to have, just make a little note of it up here, if we were to have like log base 2 of 10 and we wanted to put it in our calculator, we would have to have log base 10 of 10 divided by log base 10 of 2.
Oh.
Do you remember doing those? That's the change of base formula that we will use today as well. Good question. Anything else before we continue on? Okay. In our notes, you can use the change of base formula to solve exponential equations as well. To use, you must take the log of each side using the base of the exponent as the base of the log. So whatever the base of the exponent is what we use as the base on the log. Once you have done this, you can use change of base like we did in day 1 of 8.5, which is what we did Wednesday and Thursday last week. All right, so it says use change of base to solve. Now, those notes to me sound a little confusing. Use the base of the exponent as the base of your log. Okay, that word base gets thrown around a lot. So if we're looking at this left side, what is the base of that exponent? What is it? The base. The base is 2.
10.
The base is the big number.
Oh, okay.
So 2. Are we all okay with 2 being the base of that power? Okay, so that's the base that we're going to use when we take the log of both sides. So we're going to take log base 2 of 2 to the 3x, none of that's changing, and set it equal to log base 2 of 172. Now this isn't to say that you couldn't have taken just a regular old log of both sides like we did last week. It'll end up honestly being the same. It'll be about the same amount of work, but this is just another way of doing it. So we're using change of base to solve it.
You can use the other way though?
The other way you should get the same answer. So if it comes like to a quiz or a test, unless it specifically says use change of base to solve, you should be good to use either way, whichever way makes sense to you. Now we can still use our power rule, and where does this 3x go? Out into the front. So the 3x part would go in front of the log. So we would have 3x times log base 2 of 2 is what?
2.
Nope.
4.
Nope.
1.
1. Remember the first slide? We did that exact same thing, log base 2 of 2. So if I'm moving the exponent out in front and all I have to evaluate is log base 2 of 2, that just gives me a big old 1. Equals, and we can just leave this side alone for right now, log base 2 of 172. Do we have questions about that step? It's like the first big step. Move the power out in front. If you have log of a number that matches the base, it simplifies to just be 1. The log is gone. Now if I take 3x times 1, what do I get? 3x. And then equals, this is where we use change of base. So we can't, most of us can't type log base 2 of 172 into our calculators. So instead, we would have log of what over log of what? 172 over log of 2. You remember that from last week? Change of base. Then we grab our handy dandy scientific calculators and we can type in log 172, close the parentheses, divided by log 2, and we should be able to come up with a number. Are we lost, or are we just not feeling motivated to get our calculators out?
And then you divide it by 3.
We will in just a minute. So we've got 3x equals 4, 2, 6, 3. Right? If we round to 4 places. Okay, but I'm not actually going to round it on my calculator. I'm just going to press the divide button and divide it by what? 3. Divide by 3 to get x all alone. 2.4754.
Same.
Not exactly the same thing. Did you round it before you typed divided by 3?
I just typed in the first four numbers.
Yeah, sometimes that'll, if you type in this rounded number, it'll change it a little bit.
Okay.
So that's why I don't like to round
Just leave it
in my calculator. I just leave it in my calculator until I'm ready to write my answer. Or you can use a couple more digits here. Like I think this one was 625 or something. Something that made that go up to a 3. Do we have questions about these steps?
How would you do it
The other way?
the other way?
Okay. Like the way that we would have done it on Friday, or not Friday, Thursday, Wednesday? So we would have had log base 10 of 2 to the 3x equals log base 10 of 172. We still would have brought the exponent out in front. 3x times log 2 equals log 172. Divide both sides by log 2. And at this point, they look identical. 3x equals log 172 over log 2. See how that's exactly the same step? We just got there a little bit different of a way. So that's why it's not going to make a huge difference to me unless the directions specifically say do it a certain way. So like on your homework, I would like you to practice the new way because that's what the directions are going to tell you to do. But last week's way would get us the same answer. All right, on number 2, what base should my log have when I'm taking the log of both sides?
7.
A 7. We use the same base that exponent has. So we are going to have log base 7 of 7 to the 5x equals log base 7 of 3,000. Make sure you're using the same base on both sides.
Okay.
What happens to that 5x? Goes to the front. We use that power rule. Our exponent comes out in the front. 5x times what is log base 7 of 7?
1.
1. Still set equal to log base 7 of 3,000. 5x times 1 is 5x. And then on the other side, we can use our change of base formula. So what would I write instead?
5x equals log of 3,000 divided by log of 7.
Good. Log of 3,000 divided by log of 7. Then we go to our handy dandy calculators. Log of 3,000, close parentheses, divided by log of 7. And we end up with 5x equals,
4.1144.
I think at the very end.
It just goes all 4, 4.
Oh, really? Mine goes 445.
Oh.
So I think that it would round up. But if you don't want to round it, you just want to put a few more decimal places, that's fine. You could just put all of them if you really wanted to. Because we really shouldn't round until the very, very last step. And my last step is to do what? Divide by 5. So I'm just leaving that big number on my screen, pressing divide by 5, enter, and I get x equals 0.8229. Questions, concerns? We're sure? This shouldn't be a whole lot harder or a whole lot different from last week because half of the problem is exactly the same. Just that first step or two is a little different. Ready to try some more? I guess so. Okay. All right, I want you to try these two on your own for a minute before we talk about them. On number 4, I would recommend putting that exponent of x plus 1 like in parentheses so that you know that sticks together for a while till like the very end. But number 3 is very similar to what we've been doing. On number 3, what base will you use for your log? 5. And on number 4, what base will you use for your log?
5.
Also a 5. Okay, because that's what the bases of the exponents are on both of them. On number 3, we already said we should take log base, what?
Log base is 5.
Log base 5 on both sides. So we just write that first. That first step really doesn't require a whole lot of mathematical ability other than to identify that base 5 is what we want to use. Then what happens with my exponent? My exponent comes out front. So I have 2x times log base 5 of 5 is 1. And then we can just leave the other side for now if you want to. If you want to go ahead and use your change of base, you can. So on my next line, 2x times 1 is 2x equals, now let's definitely use change of base. Good. Log 120 over log 5. Make sure they both get their own logs. Now what base are we working in?
Division.
What base are we working with?
Oh,
Oh,
2.
no. 10. We didn't write a base down. That means we're working in base 10,
Oh.
which is why my calculator can help me out with this next part.
The handy
Handy dandy calculator. Log 120, close parentheses, divided by log 5. So now we've got 2x equals, we should have gotten 2.9746359. It went on and on, right? Whole big number. And we're going to take that whole long number and divide it by 2. So that's why I just leave it in my calculator and then press divide by 2 and round on my final answer. What do we get?
1.4873.
Good, I would agree. 1.4873 is rounded appropriately. That's how we got our x. Questions, concerns? You with me still? A little afraid I'm losing a couple of you. On number 4, what base am I starting out with?
5.
Again, a 5. That is the base from my exponent, or my number with an exponent. Now this time we said the exponent, you might want to write it in parentheses because the whole entire exponent has to go where? In the front. So x plus 1 has to come out in front. Log base 5 of 5 is 1. And then we still got log base 5 of 24. X plus 1 times 1 gives me x plus 1. Change of base means I'm going to rewrite the other side as
Log of 10.
whoop.
Log of 5.
Good. Then yes, they both have a base of 10 now. Log base 10 of 24 over log base 10 of 5. Now it's time to use my handy dandy calculator. Make sure you close your parentheses after that 24. So we have that x plus 1 equals 1.97464. Something close to that, 4635. And I already had somebody ask, but what are we doing for this last step? Subtracting 1. We need x all alone. To get it all alone, we subtract 1. And then we can just go ahead and use this to round to 4 places after the decimal point. So we get 0.9746. Questions, concerns before we move on to the back? Okay. We're going to switch gears just a little bit now. So on our notes on the back, an equation that includes a log expression is called a logarithmic equation. They can be solved by using the properties of logs and then changing the log form into exponential form. So we're going to pull together some of the ideas that we've learned so far in Chapter 8 about logs. All right, so they said we need to use the rules that we know about logs so that we would be able to write it in exponential form. Now, what do we see as being a difference between number 5 and number 6? Nope, never mind. Delete that question from your brain because there's not a difference except that the PowerPoint did not have the parentheses. Now, without those parentheses, I don't know, let's see if anybody knows where I was headed with that. Yes, without the parentheses, we could just subtract 1 from both sides. But because it should have had the parentheses like it does on your page, we cannot subtract that 1 because it belongs with the log. Does that make sense? Okay. So we have to think about if there are any properties that we can use. Anything that's going to help us be able to rewrite this. So addition is tempting. So if we think about our addition and multiplication rules, we're not multiplying two things together inside of the log, right? So instead, I think that we're going to just head straight for our exponential form. So remember, the addition worked if I were to have something like log of 3x plus log of 1. That's when I could use the multiplication or the product property and rewrite it as log of 3x times 1. Do you remember doing that?
Yeah.
But here we've only got one log already. So we're not going to be able to use that product rule. Does that make sense? Do we see how these are different? Okay. So I appreciate that we kind of were trying to use one, but I don't know that we can on this one. So let's go ahead and try going straight to exponential form. What is my base?
10.
What is my exponent?
3x plus 1. Oh, wait.
Disagree. 5, and I'm going to set it equal to what? The 3x plus 1. Are we okay with that? So this is switching gears a little bit back to what we did a couple lessons ago, putting it in exponential form. Now, we really can just evaluate this and solve for x. What is 10 to the 5th?
50.
No.
Oh,
100,000? Sounds about right. 3, 4, 5 zeros. 1, 2, 3, 4, 5. 10 to a 5th power means you're going to have 5 zeros after your 1. Equals 3x plus 1. Now we just have to solve for x. What are we going to do? Subtract 1. So my 100,000 becomes what? 99,000.
Oh,
999.
999. And then my last step is to divide by 3. So x equals 33,333. All those 9s can just get divided by 3. Done. Questions, concerns? Are we sure? Okay. So, same kind of thing on this next one. Because of those parentheses, there's really nothing I can do to change this except go to exponential form. So what is my base?
10.
My exponent?
4.
And that's set equal to 2x minus 2. 10 to the 4th is 10,000. To get x alone, what do I need to do? Add the 2 to both sides, and then divide by 2.
5,001.
We should end up with x equals 5,001. There's some big answers. Told 7th hour it's only a big number if it would be a big paycheck. And these would be big paychecks. We ready for the next one?
Yes.
We get these done? Okay. Let's try number 7. Now these ones get a little more interesting because we would actually be able to use some of our properties. This is when it gets a little more challenging. What can I do with this number out in front of the log? Where could I put it? Okay, it can become a power on the x. So we would have log of x squared minus log of 3 equals 2. If we have logs separated by a subtraction sign, and I wanted to combine them into one log, what operation would I be using now? Division. So subtraction condenses to division. What divided by what?
4x squared over 30. Okay.
4.
Where'd you get a 4?
Log x.
Oh, okay. So x squared over 3. Okay. And now that is equal to 2. Are we okay with condensing it down into one log? That's like our 8.4 properties. Now that we're down to one log, we can change it into exponential form. What's my base? 10. My exponent on 10?
2.
Set equal to
X squared over 30.
x squared over 3. Beautiful. All right. 10 squared? 100.
Where did 10 come from?
Our base on the log,
Oh, yeah.
not written, it's a 10. Now what can I do to both sides?
Divide.
No.
Or subtract.
No. Multiply. We have to undo this division. To undo division, we multiply both sides by 3. So 3 times 100 is 300 equals x squared. We still need to get rid of the whole squared thing.
Square root.
So we have to square root both sides.
Get 117.32.
Well, let's talk about this for just a second. My preferred answer would be 10 root 3. Right? We're just simplifying a radical. It's got a factor of 100. Square root of 100 is 10. And then we're left with a square root of 3. Now, if you were to use a radical in your calculator, which is not my preferred way, yes, we would get 17.3205. So I would accept that. It's just not my preferred way. If you're square rooting, we've learned how to simplify square roots without putting it as a decimal.
They have a ruler on it.
All right, on number 8, what do you think my first move is?
Power.
Somebody other than Charles tell me what he means by power. Okay, the 3 becomes an exponent on the x. So log of x cubed minus log of 2 is equal to 5. Now, I want to condense my subtraction of my 2 logs. Somebody other than Charles tell me what operation can condense them. Ajaya. Division. So we would have log of x cubed divided by 2. Condense them down using division. Still set equal to 5. We are ready now that we just have one log to rewrite this in exponential form. What is my base? 10. My exponent? 5 equals the x cubed divided by 2. All right, 10 to the 5th power. is 100,000. That's equal to x cubed divided by 2. My next step,
Multiply by 2.
multiply by 2 on both sides. So now I have 200,000 equals x cubed. My last step is to cube root both sides. Okay, when we cube root both sides, we just have an x. And then there are a couple ways to do this. If you did use a calculator to cube root it, I would be okay with it. We can talk about what that would be in a minute.
How would you cube root it on a calculator?
We'll talk about it in a minute. So if we were to be just cube rooting 200,000, for each 0, there's a factor of 10. So if I knock off 3 zeros, that allows me to bring a 10 outside. So that would be 10 times 10 times 10. Does that make sense? Knock off 1,000. And then we still have a cube root of 200 to think about. But I don't know that we can get anything else out of that. Oh, we might be able to get a 2 out of it. Yep. So if I start breaking down the 200, 2 times 100, 2 times 50.
25.
Yeah.
And then it could be 5 inside. Oh, wait, no. That can't
So the 10 that I already got brought out is going to get multiplied by what? A 2. 10 times 2 is
be 20.
20. And then we would have the cube root of what was left over?
Oh, x.
Whoa. 25 was left over.
Oh, wait, what about 3?
The 3 is just a cube root,
Oh.
right? Cube or a cube root. We didn't actually have a factor of 3. Now, in a calculator, let me just erase some of this at the top here.
I would do it in the calculator instead.
Some people have a cube root button, or some people have an X root button, like it has an X as the index. If your calculator has an X root button like mine does, you could type in 3 and then press the X root button and then put in the 200,000 and press equals.
So, which one?
So the X root is above the caret.
Oh.
Excuse me. So second caret brings up the X root. So I would type in a 3, second caret, and then enter in my 200,000. Press enter.
5,
We would get 58.4804. So I would also accept that as an answer on number 8. It's just not my preferred answer, but I would accept it. Okay, now if you have personal calculator questions, like your calculator doesn't look the same as mine, or you can't find that button, just let me know, and I can help you out with it in just a minute. In the meantime, are we ready to try number 9? Got one more. We can do it. See, it even says on the slide. Last example. In my opinion, this one isn't all that hard compared to the ones we were just doing. We don't even have an exponent we have to deal with. So we've got log 6 minus log 3x equals -2. All right. So to condense it, what are we going to do? Use division. So we would have log of 6 divided by 3x is equal to -2. Okay, now we go to exponential form. My base,
10.
my exponent, -2 equals 6 over 3x. Not pretty, but it's not awful. Next thing, let's deal with that 10 to the -2nd power. Anytime I see a negative exponent, I should know that it's going to end up being a A decimal or a fraction. Do you remember that? Negative exponents give us fractions. So normally 10 to the second power would give me what?
100.
100. But because it's going to have to then go into a denominator, it's 1 over 100 equals 6 over 3x. Now, if you are remembering, having flashbacks to Algebra 1, or in some cases geometry, we've got a proportion set up. If we have two fractions set equal to each other, the best way for us to solve it is to cross multiply. 600 equals 3x. You might have heard it said the product of the means equals the product of the extremes. It's the same idea, cross multiplying. And that means my last step is to, last step, divide. X equals 200. All done. Questions, concerns? It did. Our notes took quite a while. But do we have questions about how to do it?
No.
Okay.